Hello everyone. Let us discuss about graph theory. This is the first class of graph theory. So before going to this topic graph theory, we will discuss about the definition graphs and all important points of graphs. That is vertex, edges, loop, multi-edges, multi-graph, simple graph, all about this. So we'll start first definition of graph. So a graph G is a pair of V of G and E of G consists of two finite sets. So what is graph? Graph is a pair of vertices and edges. These two sets are finite sets. So what is V of G? V of G is the vertex set of the graph. This is the vertex set of the graph and it is denoted by V, which is a non-empty set of elements called vertices, and it is also called points, nodes or dots. Okay. Now let us come to the point E of G. E of G is the edge set of the graph and it is denoted by E, which is possibly empty set of the elements, and it is called edges. It may be empty or non-empty. So that each edge E in E is assigned an unordered pair of vertices. This is unordered pair of vertices U and V. And also we can write VU because this is unordered pair of vertices, and the end vertices, this U and V, are called the end vertices of V. So taking an example, this is a graph G and the vertex sets are A, B, C, D. So here V of G is equal to A, B, C, D. And now E of G, what is E of G is equal to, E of G equal to AB. And we can write this also BA, AB, and also this edge AC, AD, BC, and CD. There are 5 edges and we can denote these edges AB, or we can write this is E1, this is AC, E2, AD, E3, BC, E4 and CD, E5. So there are 4 vertices and 5 edges. So if E is an edge with end vertices U and V, let us take the edge E1. E1 is pair of AB. So E is an edge of with end vertices U and V. Here E1 is the end vertices with A and B. Then the E is said to join U and V. And here E1 is join of A and B. Okay. And next come to the next point. A vertex U joined to itself by an edge, and this edge is called a loop. So see this. Taking in this particular example G, we can take the vertex D, and in this same vertex another edge is joined E6, which starts from D and ends with same vertex D. This type of edge is called loop. Okay. The vertex U joined to itself by an edge, and this edge is called a loop. Here in this particular graph G, E6 is a loop. Okay, so this is a loop. Next, come to parallel edges or multi edges. So G is a graph, and if two or more edges of G have the same end vertices, then these edges are called parallel edges. So taking example, E5 and also E7. Okay, E5, see here, E5 and E7 has same end vertices, that is C and D. So E5, E7 are called parallel edges. These two edges are called parallel edges. Okay, next, a vertex of G which is not the end of any edge is called isolated vertex or isolated. That means in this graph there is another vertex E, and here E is not joined with any edges. Okay, so this E vertex or vertex E is called isolated vertex. Okay, so this is important, remember this, the E is called isolated vertex. So next come to important part of the edge, adjacent edge or neighbors. Two vertices which are joined by an edge are called adjacent or neighbors. What is this? Two vertices. So taking the vertex A and B. The vertices A and B are adjacent vertices because E1 is joined with same vertices A and B. So this is called A is adjacent with B, and also B is adjacent with C, and A is adjacent with B, also C, also D, because A is joined with B and joined with B, E3 and edge D, and also by E2 with C. Okay, so these are called adjacent edges. So next come to the point neighborhood set of V, and this is denoted by N of V, and here we can find N of A. So thus, what is neighborhood set of V? The set of all neighbors of a fixed vertex B. So the fixed vertex is A. We can take here A, and the set of all neighbors of the fixed vertex B of G is called neighborhood set of V, and it is denoted by N of V. So here A is adjacent with C, A is adjacent with B, and A is adjacent with D. So N of A is B, C, D. These are the neighborhood set of A. Okay. Next, simple graph. What is simple graph? So you loop and you remember parallel edges. So what is next? Come to the point simple graph. A graph is called simple if it has no loops and no parallel edges. So what is a simple graph? Graph G is a simple graph because there is no loops and no parallel edges. If we can draw here E7 and also we can draw here E8. So this is not a simple graph, and this graph is called multi-graph. So with loop and parallel edges, the graph is called multi-graph. Okay. Now let us start complete graph. Okay. So a complete graph is a simple graph in which each pair of distinct vertices is joined by an edge. Okay. So first of all, complete graph is simple graph. That means there is no loop and no parallel edges. So complete graph is a simple graph, and each pair of distinct vertices is joined by an edge. So taking example, this is a complete graph. This is complete graph of vertices 1. This is complete graph of vertices 2. This is complete graph of vertices 3. Next, if the complete graph has vertices, n number of vertices, that is v1, v2, up to vn, then the edge set can be given by E equal to vi vj, pair of vi vj, for vi not equal to vj and ij are equal to 1 to up to n. Okay, so we cannot join the same vertices, and each pair of distinct vertices we can join by an edge. Okay, so the graph has half into n minus 1 edges. So for n equal to 1, this is complete graph. For n equal to 1, that is n is number of vertices. So here 1 vertices, so n equal to 1. So n equal to 1 means this is 1 minus 1, 0 edges. So this is 0 edges here. Since there are n minus 1 edges incident with each of the n vertices vi, so a total of n into n minus 1 vertices, but divided by 2, vj, pair of vj equal to vji. So taking n equal to 2, there are number of vertices is 2 and n. So see this formula, half into n whole into n minus 1. Putting the value of n equal to 2, 2 cancel, 1. So this is complete graph of vertices 2 and there is 1 edge. And this is complete graph of n equal to 3. So there are, we take here the number of edges is 3, put the value 3, 3 minus 1, that is 2. So there are 3 edges. So we can see here in this graph n equal to 4, n equal to 5. These are the complete graph, examples of complete graph. And the complete graph is denoted by kn. So we can write this graph k1, and we write this graph for n equal to 2, k2. K2 graph is like this, and this is K3 graph, and this graph is denoted by K4, and this is K5. Similarly, we can draw for n equal to 6, that is K6 graph, taking 6 vertices. See here. So there are 6 vertices and we can join each pair of distinct vertices. Each pair of distinct vertices we can join by an edge. So see this, there are number of vertices are 6 and number of edges okay, this is K6 graph. Okay, so number of edges is half into 6 into 6 minus 1, that is 5, So there are 15 edges. So in K6 graph there are 15 edges. So you count this and these are the 15 edges. Let us next we go to empty graph. What is empty graph? Empty graph, or this is also called trivial graph. An empty or trivial graph is a graph with no edges. So here we K1 is an empty graph because there is no edges, and if we take this is a graph G, so this is also empty graph because there is no edges. Yes or no? Okay. So let's come to the next graph, bipartite graph. This is a very famous graph, bipartite graph or complete graph. Okay, so what is bipartite graph? Let G be a graph if the vertex set V of G can be partitioned into two non-empty subsets X and Y in such a way that each edge of G has one end in X and one end in Y, then G is called bipartite. So here the partition becomes X union Y equal to V and X intersection Y equal to phi. Okay, so here we taking this example. This is bipartite or not, so we can check it. So here first of all the total vertex of a graph divided into two parts. One is X set and another is Y set in such a way that X union Y is equal to total number of vertices, that is V. Okay, and intersection Y, that is equal to phi. And edge, what is edge? Each edge of G has one end in X and other end in Y. So see here X1, that is Y2, that is X3, and Y1, X2, Y3, X4. So there are 7 vertices. So we divided into two parts. So in X set we can write X1, X2, X3, X4, and in Y set we can take Y1, Y2, Y3. Okay, now we draw 4 vertices X1, X2, X3, X4. This is Y1, Y2, Y3. See here X1, X2, X3, X4, Y1, Y2, Y3. So here X1 is joined with Y2. So we can join X1 with Y2, and X1 is joined with Y1 and X1 is joined with Y1. Y2 is joined with X3, Y2 is joined with X3, and X3 is joined with Y3, X3 is joined with Y3. Okay, next complete, this is complete. Y2, X3, Y2, X3, X3, Y3, and Y2, X2. See here Y2, X2, Y1, X2, Y1, X2, Y3, Y1, X2, X2, Y3, X2, Y3, Y3, X4, Y3, X4. See this. So here X1, X2, X3, X4 are not joined with edges, and Y1, Y2, Y3 are not joined with edges. And here from X set to Y set there is an edges. X1 to Y1, X2 to Y2, X3 through Y3, X4 to Y3. So this is a bipartite graph. Okay. So this is a bipartite graph with vertices 7. So next come to what is a complete bipartite graph. So a complete bipartite graph is a simple bipartite graph G with bipartition V equal to X union Y, in which every vertex in X is joined to every vertex in Y. Every vertex in X is joined to every vertex of Y. So this is called complete bipartite graph. So, and if X has n vertices and Y has n vertices, such graph is called KMN graph. So taking example, if k equal to 1 and n equal to 3, so it is a complete bipartite graph, and for each x is joined with each y. Okay, so there is x set and y set, x1, y1, y2, y3. So in y set there are 3 vertices and in x set there are 1 vertices. Okay, so we can draw k13 is like this. So this is k13. Okay, next come to k22 graph. So there are number of vertices of x is 2 and number of vertices of y is 2. So we can draw this graph like this: x1, x2, y1, y2. x1 is joined with y1 and y2 and x2 is joined with y1, y2. So every vertex in x, so that means x1 and x2, every vertex is joined to every vertex of y, that is y1, y2. So this is a complete bipartite graph and this graph name is K22. So similarly we can draw K4, 4. Okay, K4. So there are 4 vertices K in X set and 4 vertices in Y set. So naming as these vertices of X, x1, x2, x3, x4, and in Y set these are the name vertices y1, y2, y3, y4, and join this x1 is joined with y1, y2, y3, also y4, x2 is joined with y1, y2, y3, y4, x3 is joined with y1, y2, y3, y4, x4 is also joined with y1, y2, y3, y4. See this is K4 graph. Similarly you can draw any KMN graph in similar method. So let us take another example. Okay, next come K110. That is a star graph. This is x1 and y1, y2, y3, y4, y5, y6, y7, y8, y9 and y10. So in y set there are 10 vertices and in x set there is only 1 vertex. So we can draw in similar way. So look this is a star graph and it is also called a complete bipartite graph because in we can draw this graph in this method. 1 2 3 4 5 6 7 8 9 10. This look different graphs, but these two graphs are same graph, K110 graph. Okay, so thank you.